Hello, today is, oh, just double checking it. Is that one? No, it's not working. Today's all about triangles. We're going to discover the mysteries of triangles. So let me see what you can see. Yes, indeed, we're good to go. So it's about triangles. We're going to need a pair of scissors, a pencil or a pen, a ruler, and some scrap paper. We're going to cut a number of different triangles up. At 10 o'clock, we're going to be doing something for early years. So if you're 4, 5, 6, you can do both. Then 10 o'clock, in an hour's time, we'll be doing something specially for you. And now we're going to be doing something immediately. If you are 7 or 8 or 9 or 10 or 11, this will be immediately suitable for you. And if you're older than that, if you could stay and help the younger ones, that would be amazing. And you might even enjoy what we start off doing. Well, if you're me, you'll enjoy it regardless. So it means you can start at a lower level and learn things about triangles and what the primary school kids, the 7 to 11-year-olds are going to learn right now. I only learned yesterday. I don't write these resources, by the way. I'm not a teacher. My life's purpose is that every child would love learning and enjoy maths, and I do that through Bubbly Maths. And so all this detail that I'm presenting to you is being written by a wonderful woman called Tony. And I'm learning so much. I'm really loving it because these are things that I maybe did know when I was in school, but I've forgotten it all. So yeah, so what we're going to do is we're going to start off with a piece of paper. I've got some scrap paper, and we're going to cut out a triangle. Yeah. Ooh. So only use scissors with permission, the right scissors. In fact, what we're going to do, maybe draw it first. So I'm going to draw a triangle, but what we do not want, the opposite of what we want to draw a triangle that is, actually we'll do it this way around. We don't want one using the square, the right angle. We don't want a right angle. We're going to start there. We're going to draw a long line there, and then I'm going to come down here. Okay, that's what I'm about to draw. And I can do it. Actually, I can do it for you on here, because I can tell my lovely camera that I got is something wrong. I haven't worked out how to solve the problem yet, so I don't want you to see this side yet. I'm going to turn it around, and that is from the presentation we did the other day, video we did the other day. So we don't want that light shining on it. There we go. We'll do it that way. And get rid of that. We were doing all about mass and the difference between mass and weight. If you right, so what we're going to do is, you saw that sheet of A4 paper. I'm going to do this roughly. So we had the sheet of A4 paper. It's roughly that big, more or less. Whoops, there we go. Now what I want you to do is make a triangle that's got like a long end there, and then, so that is more than a right angle. That's what we want to do. Okay. So that's what I'm going to do now. I'm going to cut my piece of paper that I had here. Here we go. I'll leave that for you to look at. You can draw yours and then cut it. I'm using the long part. I'm starting on the base and I'm cutting along. So I've got a nice big triangle here, and now I'm going to go straight down to there, but I'm going to use a ruler so that I get that line straight. So here's my ruler coming down. Oh, that's not straight. I'm going to use your ruler for both. You use your ruler for both, and then we'll be in good shape. There we go. And the ruler down there. Whoopsie. I managed to draw on my finger as well. Okay, so that's what I've got that I'm cutting out. There you go. I'm going to cut that out now. And boing, 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 boing. Sandman, give me a triangle. Ba-dee-da-dum, ba-dee-da-da-dum, bum. Okay, so we have a triangle. Now that we've got a triangle, what we're going to do is we're going to take either end and we're going to, wait a minute, let's get this right. We're going to fold it right on that upper vertex along this long base. We're going to fold it. We're going to fold it so that, whoops, there it is. So the top bit, so that that top vertex is the top of the fold, and the gut. So I'm going to just hold that. I'm going to pinch that because that's got to be exactly there. But where we want the bottom to go is, this is going to be very long, it's going to be interesting. See how this works. Where we want the bottom to go is we're going to follow it exactly along the base. So the base, this part here that we're folding over, this part here that we're folding over, that, so we will start off with the whole bottom base. It's still going to be following that bottom base, and the place where we're going to fold it is exactly along, starting at the vertex where the two angles, where it changes, so the top vertex of this triangle. So it is a little bit fiddly, and I'm going to do it flat down for a minute because it's much, much, much easier to do if you do it on a flat surface. So I'm just looking down at my triangle and I can't use my visualizer because my visualizer is not working. So if you just look down, you're going to make sure that the bases, let's say, of the two triangles are following exactly. Now the precision here really does matter to get a beautiful effect. We've got a lovely surprise coming your way. Mine isn't perfect, but you can see that edge there, the edge that goes between the base and the top vertex. Now wait a minute, what sort of a triangle is that? That's interesting. Okay, that's very interesting. Now, let's see. This is where my brain goes blank. There's me, I think I've got it all, and then my brain goes completely blank. From A to C such that, and then mark the point R. Oh no, we've got to mark the point R. We've got to mark this point here. That point we're going to call, turn it round, do it this way round. So we can see it, we're calling this point R, and I'll get on here so you can see more easily. So we've now folded that over, and this point here is called R, that's a fold. That point there is called A. I don't know which way round you're seeing it, so I'm going to write them both way rounds in case it's reversing it. I'm not sure if it's reversing it or not. And then we've got, this is point C here. If it's reversed, then that's a C-ish. And this is point B. And if yours is reversed, then I'm going to write the B reversed. I do not know whether or not you're seeing this reversed or not, but I'm going to write these letters on my, I've got my sheet slightly different, so that's fine. I'm going to do it the same way around though. R, C, and B. Now I've got that done. Let's see what the next stage is. So I'm just using, oh, let me just put this in the comments, and just realized we don't actually have I haven't given you the link. Got to give you the link. Right, hold on 1 second. Hold your horses. Hold your horses. Let's see. Here we go. I'm going to give you the link to this activity so you can print it out. So this will be for afterwards. You can go ahead and I've got to find it. I think it should be on here. It just should be have come up, but it didn't. Got to find the place where the live is, and then I'm giving you the link so that if you don't have to print it out, you can just look at it. Here we go. Whoopsie, the link's going on now, and silence that, so it doesn't make a noise. And then while actually I may as well start a watch party while I'm at it. There you go, we'll have a watch party so we can have other people coming along as well. And that's, we're calling it Unfolding the Mysteries of Triangles. Unfolding, that's what we're doing. We're wait a minute, are we folding or are we unfolding? Which one do you think we're doing? Are we folding or unfolding? Or are we folding and unfolding? Whoops, triangles. Start that, and then I can add the link onto the bottom of that one. Here we go. Right, something, I've written something. Kerpow, kerboom, I've written something, and now I've got to find you again. Where are you? I've lost you. You've disappeared. Where are you? No. I'm just going to go over here and have a look over here. At least I'll see you there. Good. Right. Now, the next thing we have to do, I'm just following the instructions. So this way, you've got the video of it. So when you get yours, you can follow the video again if you want to. Now, so now we're going to fold B along, fold B along to R. Like so. So we started the first fold by folding, we're going to call it C, across, so that the top vertex was the same. The top vertex of the new triangle is the same as the top vertex of the original triangle. And then what was super, super, super important is that this line, these two, the base remained the same, exactly the same. It followed along exactly along the line of the original base. So the first question is, what do you notice about this line here? What do you notice about this triangle and this triangle? So that's observations. What can you tell me about this angle and this angle, this new angle of these new triangles and this angle? And what do they add up to in all? Let's start there. Okay, now the next thing you can do is take B and fold it over so that it ends exactly at R. I'm going to now go and do that down here. So I do it very precisely as I can. There we go, and then fold it. Okay, so you're folding that along there to there. Right, okay. So now we've got that triangle going across there, and then we've got this one over to here. And now what we're going to do is we're going to take, this is our guiding line really, but it's created these other two lovely triangles, which are giving us revealing some secrets already. And now we're going to take C and fold it over to R as well. So we kind of have like a napkin at a party, except it's folded flat. Okay, so if that were with a napkin, that would be quite a pretty napkin, wouldn't it? So I'm going to now take that and fold it very carefully so that this vertex ends at R. I'm going to fold this here very carefully, but I'm going to do it down on a flat surface so that if I had my visualizer, you'd be able to watch me doing it. But my visualizer's not working. So that puts paid to that idea. Right, so now we've got, oh look, It does, doesn't it? Does it look like, mind you, who sends letters these days? It does look like a little bit of a wonky envelope. And then we've got another shape being revealed here. What's this shape here? What about that one there? So you know what? It does look like an envelope. So I am going to close the envelope, except it's going to be a bit of an odd envelope because it's not going to have any overlapping pieces at all. Zero overlap. I'm going to fold this down so that the top, the vertex, again, comes down to R. It doesn't go past it, doesn't stop before it, folds down exactly to R. So I'm going to fold that down like that, and now I'm going to do that down here. You do yours. So we don't have any overlaps. And if I've done my folding well, which I haven't done it perfectly, I have to say, then you should have two. Let me see, I'm now going to lift it up and we're going to look at the back. What do you have at the back? That is indeed a rectangle. It really is a rectangle. And if we look at this side here, you have the same rectangle made up of the outside triangles. We folded in the triangles, and now we've got one rectangle on the back, which is just a rectangle, nothing more, nothing less, and another rectangle made up with the rest of the paper, made up of 3 triangles. Now my next question to you is, does this work for every triangle? So I would love you to go ahead, go away and cut up a load of different shaped triangles, all the shaped triangles you can think of, and then fold them up using the same instructions and see if the same thing happens every time. I hope you like that idea. I like that idea. Right, so that's what we're doing with primary. I think. Then let's see if there's anything else that I've forgotten to tell you about. Look at my cheat sheet. I love my cheat sheets. Thank you, Tony. Okay, so we're doing, let's see, I might have some questions for you here. Let's see, I've got some questions now that we've made this, and yeah, I'm going to now reveal. It's the big reveal. I've got this one this is one I made earlier. So I've marked all the lines on here so that it's easier for me to, is it actually easier if I show it here? No, you know why? Because I'm going to be moving my hand and it's in the opposite direction, and it'll actually be easier if I do it this way so I can point at the things that we want to be asking about. So the questions are, let's see. What do you notice about angle ARB? So this angle here between the line from A to R and the line from R to B. What do you notice about that angle there? Question number 1. We were doing that as we were folding. And then you made the triangle, folded it all. So what you can do with your triangle is is you can draw, now that you've made all the lines, you can draw them. And indeed, you can draw, see those lines there? You can draw those lines on as well by literally getting a ruler and drawing down, following the 2 triangles, the folded over ones. You can draw that one, draw that line, draw that line, draw this line, draw this line, and then have a look, see what symmetries do you see? Which angles are 90 degrees or right angles? Now, I've got a question here that I've got to work out. It says, where is the foot of the perpendicular from A to BC? So from A, the perpendicular from A to BC. So where so the perpendicular to BC is the line that's at 90 degrees that goes up. So going down from A to BC, where does that perpendicular lie? So do we already have that spot, or do we need to make a new spot? And if it is one of these spots, what letter would correspond to that point on the triangle? And then here's one of the kickers, and this is one of the ones I love most of all. What lengths are equal? Now, if we have any equal lengths, now we've drawn that line ourselves based on, we've drawn that line by folding this down. So we know that that line is equal to that one. I'm saying no more than that. But also, what about along these lines? Are any of these lengths, like the one we've drawn there, which lengths are equal? What about these ones? Which lengths are equal here? And if you're not sure, you can, or you've got your envelope to draw it. So you can say, well, I don't know if this angle, if this length is equal to this length, for example. So what you can do is you can use the paper you've got and fold it over and see, is it equal? If you're not sure, you want to know if you've now drawn that one there, you fold that over, is that equal? Is that length equal to that one? Is that length equal to that one? You can literally fold your triangles, your paper round and see, or measure it. You can measure it with a ruler. And then also which angles add up to 180 degrees. Well, so that there, well, all of those add up to 180 because they're on a flat line. But if you fold it over, which other angles line up, add up to 180 degrees? Questions. So that's, now to me, that is the upper primary. If you're up to age 11, you're set. Go off and answer all those questions. And although, yeah, what we're going to do now for lower secondary is we're going to look at the area of a triangle. So if you've already started looking in school at the area of a triangle, you might find this interesting. Have you heard half the base times the height? If you have, then this is going to be of interest to you. Now, I learnt half base times height when I was in school. And then as soon as I left school, I forgot half base times height. And years later, when I started to do maths, because my mission in life is that every child on earth will love learning and enjoy mathematics, well, I had to learn some maths again. So I learnt again half base times height. Okay. And then I had to learn a formula for the area of a triangle. Okay. But my question has always been, why? And I do seem to remember in those days we had blackboards. We didn't have any interactive whiteboards of any description. It was all blackboards. We didn't even have a photocopier. Oh, don't tell anyone that's how old I am. In my school, we only just got this kind of weird copying machine that the teachers had to actually write out and draw out everything on this weird yellow paper. Get this, is so, and then they had to go to the machine and they had to go clonk, 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 and make sure they had enough ink, and it got in a big mess, and they had to go clonk, clonk, and literally they had to write out the whole assignment on one sheet of paper, and they didn't have very many, so they had to write it really small. So then we'd get them and they'd be super small. So yes, anyway, that's my school life. But half base times height, I'm sure this was covered, but it was covered. I never got a triangle in my hand, and I never saw it for myself. Well, are you ready? Are you ready? Now, are you ready? Are you sure? Okay, we're going to look at this. So, what you can do is you can colour in the areas. I'm just going to show you this. So it's on the resource. You can colour in the areas like so. Okay, so we could do that quickly. Problem is I can't show it to you. So that's what I'll do. I'll leave that on there. You colour in your areas and I'll colour in mine. So you've got, now what shapes have you got there? Can't focus it, just relying on the camera to autofocus that one. And right, so I'm going to go with blue. And then the other thing is, what are the shapes? What are those different shapes? So I've got blue, I'm colouring in my kite. Blue, what? That's not a kite. I'm doing the wrong thing. No, I'm not. No, I'm doing it right. I'm doing it right. That is a, do you know what? When I looked at that just now, I was thinking that it was just an equilateral with no particular symmetry. But I'm looking at it again, and I'm wrong. It's looking at it from this angle. It's giving me a different perspective, which made it look as though there was no symmetry. But I think I'm wrong there. Right, I've got this one coloured in. La di da 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 da. I've got my BPS coloured in. No, BPS. No, it's not BPS. It's BPR coloured in. And now I'm going to colour in my QRC. Come on, QRC. What colour are we going to make you? We're going to make you green. No, we're going to make you red. Bit of contrast. Will that be contrast? Not sure. Purple, red. I think red will be a greater contrast. No, not too much of a contrast with the orange, but I do like those colours. What flag is orange, red and blue? Is there a flag that's orange, red and blue? I know my triangle is orange, red and blue. So there we have. Got my triangle, orange, red and blue. Now, what are we doing? So now we can see we're looking for congruent triangles. So triangles that are the same as each other. And if you, let me see, now we're going to draw, I'm going to draw in that rectangle, the one that we found on the back. If I fold that in again, if I fold those two in, the only thing I can see is this. I fold that in, we can't see any. So these, why was I doing that? Anyway, so we can look, we follow the instructions, you can find congruent triangles, and then, so again, just as we did before, have another look. We're looking for, wait a minute, wait a minute. There we go. This is what we're looking for. Never mind everything else. For right now, this is what I wanted to look at. So if I fold that down, would you agree that this is the height of the original triangle? If I fold it down, that is now half the height of the original triangle. So that is, as my pen, it's half h over 2. And my pen has disappeared, maybe it's this one. So that's h over 2. That height, that bottom half of the total height is h, and the bottom half is half of that. Literally, we folded it in half because that piece of paper is folded in half. That length is the same as that length, that's h over 2. Right, now, what else have we got here? So the height of this rectangle is half the height of the triangle. Now, what we have here, we have taken the base of the triangle and we folded that over, so that plus that is half of the base. So that width there is half the base, because the whole base, it goes all the way across, has been halved, because you can see it if you literally turn it round. That plus that equals what's left over, so that is half the total base of the total triangle. And so we have a formula connecting our base and our height, because with a rectangle, we know that that rectangle, just looking at the rectangle, forgetting about the triangle, the rectangle is half the base, and I'm just going to write it here. I'm going to write it on here now. So this is h over 2, that's half the height, and this here is the base, is half the base. So the area of that little rectangle there, which is just the length times the width, which is half the base times half the height times half the base. Okay, which is, well, we'll just leave it at that, just keep it simple. It's half the base times half the height. That's that little rectangle there. So what is the area of the rest of it? That triangle plus that triangle plus that triangle. How do we know what the area of those missing pieces are? Well, we just get our triangle and we fold it over, and hey, boom, kerpow, kerbang. The area of those three triangles combined is the same as the area of that rectangle. Look, that missing bit, that missing bit, and that missing bit, the area of those is exactly the same as the area of the rectangle in the middle, which means that the area of the whole rectangle, the whole triangle, is the area of that rectangle plus the area of these three. So it's basically 2 times. So it's times 2. So all we need to do is it's times 2, so we can put it in brackets if you want, but it's all timesing them together. So we just 2 over 2 is 1. So all we're left with is half. Let's do it, half the base times the height, or the height times the base over 2. But in the way we usually say it is half the base. Whoops, half the base times the height. That's the way we usually write the formula. So that's, oh, could you not see? You can, oh no, you couldn't see what I was writing. So, so I'll just do it one more time. I'll do it maybe higher up. Do it one more time. So we had that rectangle is, can you see this? Yes. That rectangle is half the height times half the base. That's that little rectangle, simple, 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 length times width. That's the area of a rectangle. And we saw that these 3 triangles combined are the same. So the area of the whole triangle is simply twice that. And we can, and so we can, it doesn't matter, because 2 over 2 is 1. And for some reason, I don't know why that bit, I've got to find that out yet, but we write it as half the base times the height, or you can write it as half the base times the height. There's lots of different ways of writing it, but the point is it's just that rectangle twice. That's why it's half the base times the height. That is something that bugged me. It's like, okay, I've got to learn it, but I don't really understand what it means. And doing this reveals what it means. And look at that. We can do lots of colouring in, by the way. So you see, I told you if you were in primary, you could still be totally involved in this without even. And what you can do as well is you can colour in the rectangle. I'll do that on the other side. Another thing you can do is colour in the rectangle. I mean, you can literally just cut them off and paste them on and colour in the rectangle. And then, and let me see, I'm going to do it the other way around. You can colour in the rectangle just to prove to yourself that it's right. On the other side, we've got the rectangle that's half the base times half the height, because it's length times width. So we're colouring that one in, and then I'm going to colour in the other 3 triangles one other different colour. I'm colouring in the rectangle, and then I'm going to colour in the other 3 triangles a different colour. And then instead of folding them over, I'm actually going to, you can do it lots of different ways. You can experiment in all kinds of different ways. That's it. There you go. You can cut those out if you want. I mean, we can fold these over. In fact, I can fold those over now and show you that we now have one solid, one rectangle made with those 3 triangles. There you go. That's a nice way of doing it. And you can cut them out as well and do it like a jigsaw puzzle and stick them up on a wall, make a little project out of it to remind you that half the base times the height comes from the fact that there is a rectangle. We haven't spoken about what these 2 points here, we're going to talk about them in a minute. Right, this is quite a long session, isn't it? But I'm very excited about this because for me it answers lots and lots of questions. So the key questions you've got, I'm just going to combine now for questions for all the different questions for the different years. So for older learners as well now, we're going to go with, I'm going to point at this one again. You can be looking at that there. So we've got, again, which angles are 90 degrees? What do you notice about the small triangles inside the big ones? Any small triangles you can find, look at the properties of them. Which pairs of triangles have the same area? What shape did you make when you folded A, B, and C to meet R? We've covered that. Can you see the rectangle? Looking at that, can you see the rectangle? And which triangles are inside the rectangle? And which triangles are not in the rectangle? And then tell somebody else, go and explain to somebody else how this, what this shows about the area of the triangle. Go and teach somebody else. Now that you've done it, you do it over Zoom, do it whichever way you want. Go and show somebody else. You can show a little person by drawing, by colouring it all in. And then, so for older learners, again, just do this yourself. Do this, do the drawings. For older learners, you can do the drawings. You can make all the connections with the drawing as well as, by all means, do the colouring in. For me, the colouring in has actually made a massive difference in my understanding. I'm 58. I'm 58 years old, and I'm just getting a better understanding now of triangles. I'm an engineer, for crying out loud. I did you know, advanced maths in A-levels and engineering maths, and I'm just now really getting to grips with triangles. So actually, I highly recommend getting your colouring out and really getting to grips with it and drawing the rectangles and drawing the different things, so that when you look at that, you can visualize all those different properties of a triangle and know that. So when you have to work out area, when you're given a random quadrilateral, you have to work out the area of different shapes. You work out the area using triangles, what you know about triangles, and that, if you've got the triangle knowledge, boom, you're in good shape. Okay, so then what we're looking for, the older learners, is we're looking for what lengths are equal, what angles are equal, which triangles are congruent, in other words, exactly the same. So if you cut them out, you can move them around and they'll be exactly the same triangle, or that, yeah, if you cut them out, they'll be exactly the same triangles. You've cut that one out and placed it on top of there, have exactly the same triangle. Which triangles are congruent? Which triangles are similar, which means they've got the same angles and the same proportions, but the lengths are different. And so are there any enlargements? Find the enlargements and talk about them. And then what symmetries do you see? Any mirror lines? Find the mirror lines and describe the mirror lines. Show somebody else the mirror lines. And so you've got the lines of symmetry. And what about reflections? Find all the reflections you can find in that picture. Okay. Now for years 11, for older learners, 16 to 18-year-olds, there are activities, basically it's what you want to be doing is, again, looking at the diagram. So there's no guessing, because optical illusions can fool you. Think, oh, that looks right, and actually it's totally not. So you need to look. What I'm doing as a demonstration is not a proof, although folding paper is nice. Again, it's not a proof. You want to be working on proofs. And if you download the resource, then there's help on there for you to get your head around actually writing a proof and how to write it. So it looks a lot like this. Let me just show you what it looks like. Hold on. So yeah, so for the older learners, we've got things like, we've got a theorem, and then we've got the different ways of actually writing it. So get your head around that. And so this is, as I say, this is an activity that you can get a better understanding and a great memory aid for how to do it, but also for your older learners that actually need to be able to write a proof. That help is in the resource. That's down in the description. And that's it for today. Thank you very much. I hope you enjoyed it. I certainly enjoyed learning an awful lot more about triangles that I didn't know before. And I'm just going to have so yeah, please do subscribe to our YouTube channel, which is Bubbly Maths YouTube channel. And there's the Maths Toys YouTube channel. So that's youtube.com/maths toys. It's in the links are in the announcements and the pinned post on the Facebook page. And then please do, if you are finding this is useful, please do share. This is an open group. You can share it. Please share it on your this live or any other live or any other post. But please, if you find it useful, please tell your friends about it if you think it would be useful to them. And if you can just share this on your page, that in your Facebook profile, that would be amazing. And we have at 10 o'clock in 15 minutes, we've got another session for early years. Now I'm looking for the live, see who's joined us. Okay, and we've got Casper. Good day, Casper. Russell Wells, Nimi. Hi, Nimi, all the way in India. Barbara Davis, thank you for joining. Ian McGregor. Henrik. Hi, Henrik. Nimi again. Steve Benton. Hi, Steve. And James Jackson, thank you for joining. And I never did find the other live, so I'm sorry if you've made any comments, but I couldn't find it and I didn't want to spend extra time looking for it, so that we could just get on with the exercise. Now, yes, 10 o'clock, 15 minutes, we'll be doing the live for the early years. And so what we want for that is, if you can't be actually with them, please do cut out a load of different triangles, all different shapes, as many different shapes, as nice big ones. So not this one, this is my actual working sheet. So cut out nice straight triangles, as nice big ones. You can start with just draw straight lines and just cut out. You can get two triangles out of each piece of paper, different shaped triangles, so that they can have those ready and be folding them. So we're just basically going to fold and color and fold and color triangles. And then tonight at 8, we've got our introduction for tomorrow's activity. And then, yeah, and then again tomorrow morning, same time here. Thank you for joining. Right, looking for the button. Bye-bye, thank you.